All right, here we go. 4.2. Take the zero product property out for a spin. For each equation, find its solutions or solution or solutions. Be prepared to explain your reasoning. Okay, here. You guys know how to do one, hopefully. You're trying to get x all by itself, right? You got -3. We're going to do the inverse operation. Inverse means opposite. So to cancel out -3, we're going to add 3. So let's see. Purple for inverse operation, +3, +3. X is going to equal +3, it looks like. Next, x plus 11 equals 0. I think you guys got that one. We just did the first one. Just do the same thing we did in number 1, right? How are you going to get rid of the +11? Do the opposite. Next one is 2 steps. First, just add 11 to both sides. You're going to get 11 over here. Then you got to divide both sides by 2. You're going to get 11 halves. Or, what is that, 5.5. And then they keep adding an additional steps. So one thing I like about this, they're giving us one of the answers kind of here. Let's go back. Sorry. Let's take a look back up here. Remember over here when we saw G times H equals 0. Well, this is where we use our zero product property. If you see multiplication and they equal 0, we can go ahead and assume that both of those things are going to be equal to 0. So G could be 0, H could be 0, or maybe they're both 0. Now we're going to apply that down here on number 4. On number 4, so here we got x times all this stuff. So we can go ahead and assume that x could be 0 right there. Because of x could be 0. Up here in the previous one, we noticed that x was 11/2 or 5.5. And so we see that they gave us that same thing down here, right? 2x plus 11. So x could be 0, which I'll highlight in blue. The reason x could be 0 is that x right there. The reason x could be 5.5 is because of, maybe we should highlight this in orange. Or 5.5. So we got 2 answers here because of our zero product property. And it makes sense to have 2 answers. Why? Because every quadratic is shaped either like that or maybe like that. But a lot of times you're going to have a place where you get these 2x values for the same thing, for the same function, basically. Now, let's see. The same y value give you the same 2x's. Now, you're going to keep doing that, all right? You're going to have 2 answers. I guarantee you, in 6 through 7, you're going to set x equal to 3, x minus 3 equal to 0. You're going to set x plus 11 equal to 0 and solve for those. So let's write this out here. Maybe we go to this green color. Just set x minus 3 equal to 0 and x plus 11 equal to 0. All right, so now we're just focusing on question 5. So you're going to figure out what x makes that equal to 0. So if we do our inverse operations in purple, I would add 3 to both sides. And over here, I would subtract 11 from both sides. So x could be 3, or x could be equal to -11. And here's these 2 answers. And let's see, let's get a different. What if I highlight this one in red? This one came from right here. And in this green color, was that going to show up? This one highlighted in green came from right here. And those make those equal to 0. And that's the way we find our horizontal intercepts with a quadratic. They are directly related. So now take that information and see if you can't solve these other two. Look, there's 3 answers in here. There looks like there's 3 solutions in number 7. Which x value is going to make all this stuff equal to 0? When x is 0 right there. Here's the -3. Do some inverse operations for number 7. Just basically, you would scratch this out kind of and just pretend you got 3x minus 4 equals 0. Add 4 to both sides. Divide both sides by 3. See what x could be to give you a 0 in that factor right there. It's the same way we find our horizontal intercepts. And try to do some of this work on your own. See if you got this.